Coolant leaks are one of the most common car problems that drivers face. When you see coolant leaking from the bottom of your car, quick diagnosis is essential to prevent costly engine damage. Modern vehicles use sophisticated cooling systems with extended life coolants that can last up to 200,000 miles. These systems include advanced monitoring and leak detection capabilities integrated with the engine control unit. The first step in diagnosing coolant leaks is a thorough visual inspection. Check the color and consistency of any puddles under your vehicle, examine the coolant reservoir level, and inspect all visible hoses and connections for signs of leakage or staining. The most common sources of coolant leaks include the radiator, which can develop bottom tank failures and core corrosion, and the water pump, where seal failures and housing cracks frequently occur. Other common leak sources include aging hoses and connections that become brittle and crack over time, and thermostat housings where gasket deterioration and housing cracks can develop. If visual inspection doesn't reveal the leak source, pressure testing is the next diagnostic step. The cooling system is pressurized to 15 to 16 psi, and technicians monitor for pressure drops that indicate where the system is losing coolant. For elusive leaks that are difficult to locate, advanced diagnostic methods include UV dye detection, where fluorescent dye is added to the coolant and UV light reveals the exact leak location, and thermal imaging cameras that show temperature variations to identify hidden leaks. Professional diagnostic techniques show high success rates. Visual inspection identifies about 60% of leaks. Pressure testing combined with visual inspection achieves 85% accuracy, and advanced methods like UV dye and thermal imaging reach 95% diagnostic accuracy. Once you've identified the source of your coolant leak, the next step is repair. The approach and cost will depend entirely on which component has failed. Common repairs range from simple hose replacements to complete component overhauls. Each repair requires specific procedures and tools to ensure a lasting fix. Water pump failures are among the most common and costly repairs. This component circulates coolant throughout the entire system and requires careful replacement procedures. Repair costs vary significantly based on the failed component. Here's a breakdown of typical repair expenses you can expect. Using the correct coolant type is critical for preventing corrosion and ensuring system compatibility. Modern vehicles use different coolant formulations with specific properties. The automotive industry is rapidly evolving with new technologies for cooling system maintenance and diagnostics. These advances promise more reliable and efficient vehicle operation. Internet of Things sensors are being integrated into cooling systems for real-time monitoring. These sensors can detect pressure changes, temperature variations, and early signs of component failure. Artificial intelligence is revolutionizing diagnostic capabilities. AI systems can analyze patterns in coolant system data to predict failures before they occur, potentially saving thousands in repair costs. Smart coolants with embedded sensors represent the cutting edge of cooling technology. These advanced fluids can monitor their own condition and alert drivers to potential issues before catastrophic failure occurs. Environmental regulations are also driving innovation in coolant technology. Stricter disposal requirements and recycling mandates are pushing manufacturers toward more sustainable coolant formulations and longer service intervals.